Hello and welcome to exercise 3, which is the last exercise in the DFC course. In this exercise, we're going to be working with importing yearly shapes, adding transformation processes or technologies to our transformation, and optimizing the model. In this exercise, we will be working with optimization of the energy system, which means we are starting from a very different start set than in the other exercises. Here, we have a situation where the energy demands for EVs and air conditioning is growing or are growing. So they will need their own shape curve, where otherwise they have been on just a generalized shape curve in the model. Then also we will need to include solar photovoltaics, PV cells, to see if they have a place in our system. In other words, to see if the system will recognize solar photovoltaics as a good technology and will choose to invest in them. So the tasks for this exercise. You will need to add yearly shapes from the Excel that's on SharePoint to the model. You should add all the shapes that are, and you will need to do some data manipulation inside of Excel to make sure that Leap can actually import them. You will need to replace the general yearly shape for ACs and EVs. So make new yearly shapes for these for ACs and EVs. There are different options, and you will have to replace the yearly shape that has been listed for these technologies, and these technologies are already in the model. So you just need to replace the yearly shape. For EVs, it depends on which scenario, which yearly shape you should use. So be aware of that. Then you also need to make solar PV an option, meaning you have to make it as a new process in the electric generation down in transformation, using the data from the other Excel, the one called, I think, solar PV. Then you need to make 3 scenarios: a baseline, solar, and solar plus slow EV charging. So the task for the different scenarios. Since this is optimization, you don't have to do too much in this model. It's well prepared for it, but you will have to spend quite a long time letting your computer run the optimization. On my computer, it takes about 15 minutes to run the 3 scenarios, so be aware of that. So in the baseline scenario, you need to have the replaced load shapes, meaning adding the new load shape and adding them to the different demands. The EV load shape will have to be EV fast, that you can see in the Excel, which one that is. And the solar PV max capacity addition, meaning how much the optimization can add of solar PV, should be 0. That is how we define that there will be no addition of solar PV in our optimization. That's what we do to keep it out. In the solar scenario, which is a scenario you have to make, you will have, just like in the baseline, we replace the load shapes. And the EV load shape should be EV fast, so that will work quite well if you let it inherit from the baseline. The only big difference is that the solar PV max capacity addition needs to be quote-unquote unlimited, the measure of unlimited in our transformation sector, so the optimization freely can choose to invest in this technology. In the third scenario, which is a solar and slow EV charging, you have to replace the load shape, just like in the 2 other scenarios, so that's not a change. You will have to have the EV load shape as EV slow, so that's a change to that. You will have to have a different year shape in this scenario. And the solar PV max capacity addition should be unlimited, just like in the solar scenario. It is recommended that you let the solar plus slow EV charging inherit from solar, since the change is basically just one yearly shape you have to choose instead of another. So for this exercise, I want you to give me 2 major results. The first one is, what is the PV capacity in a solar scenario in 2040? So that is the capacity of PVs in 2040 in megawatts, and I just wanted it in a whole number. I should note it that you can choose how many decimals you want to show in your results in a table form. So if you set that to 0, you will just get the whole number by itself. The second answer I want is, how much output is there more in the EV slow plus PV scenario compared to the EV fast PV scenario? So that is the cumulative production compared to the EV fast scenario in 2040 of terawatt hours, and I want it just for all of the different technologies. So does EV slow cause more production of electricity to happen, or does it decrease it? If it's a decreased number, put a minus in front of it. So that is the cumulative production compared to EV fast in 2040 in terawatt hours, and again whole numbers. As an added help, I will show you now how to do named ranges in Excel, which is something you have to do when you are importing yearly shapes in Leap. There are two conditions for importing yearly shapes. One is that all your data is in one long form, so in one single column. The second is that it is in a named range, so that's what you can choose in Leap. And I will show you how to do that now. So the first condition is that you reshape your values to be in a one long form, as so here, otherwise Leap will not read it. And then up in formulas and define name, you can then choose your name for your named range, or make a named range. So here I just called mine general, and it will then refer back to your data. When you've done that, you can see that in the name manager in Excel. So you can see we have one here, general, and we would have multiple if we had made multiple, as you should probably do. Then in Leap, when you have the yearly shape and you import from time slice shape, you'll get a box where you can see the different, we will add a new one because it will override the one you have chosen. So we are just making a new one, that is test. And you can import from a time slice shape. And then you get an Excel range, which you just defined, and that's the name that we gave it. There could be multiple options if you click the arrow, if you have more of them. So you make sure to take the right one. Then click OK to that, and your data should come in. So we just do that. And they will replace 80 data. That's fine. We just have some random data that Leap gave us otherwise in the test. So we say yes to that, and here it looks a bit random because it is randomized numbers, but it should look a lot more general for you as it would fit with the data that you put in. So kind of a little bit more like a proper load shape. So that's how you add load shapes from Excel into the Leap dataset that you will use in this exercise 3. The only thing I have left is to say good luck with the exercise 3, and remember to note down your results. After this exercise, if you've completed all of them, you can go into our SharePoint and find the link to the survey. It is in the same folder as your starting files, where you can fill out your results, and you can put them into and you can submit your results, which you need to get your certificate. Good luck!